research group? Do we want a mailing list? Do we want another workshop? Another goal was better understanding of how the transport should and must evolve, including looking at the applicability of present transport to specific use cases. So this sort of was an overlap with the task force. Interface improvement, exposing more of the applications about the transport in the right way, and a question we ends hard and then shying away from were the trust issues and deployment incentives and cooperation evolution approaches, right? So every time we've tried to do this sort of signaling to the path or from the path, there's always been the question of, well, how can I trust what is said? How do I know who you are? How do I know that the signaling has not been modified on path? And the trust issue is just, unless you have, a perfect solution to the keying and key distribution problem, this is hard. And if you have a perfect solution to the keying and key distribution problem, then everything is easy. So one of the things we talked about was measurement. So the measurement fell out relatively early on in the discussions. We didn't spend a lot of time actually talking about measurement because there was pretty clear agreement in the room as to what the next steps were. And those next steps were more or less the hops barb off on Sunday night, and we'll talk about that in a minute. But really, the question here is, okay, well, we're making engineering decisions about the evolution of the protocol stack, and these are based on not a whole lot of data. We need more data. If we're making an argument that you'll never be able to deploy a given protocol because it only works in 99.5% of the internet, maybe we can put some effort into engineering around that problem. And if it breaks in 0.5% of the internet, how much complexity to engineer around that is too much? So there's a trade-off here. And Aaron will talk more about the hops barb off and the outcomes of that, which is actually the most productive I've ever been on a Sunday night at 9:30 p.m. after 4 beers and an 18-hour day. So on the middle box cooperation thing, we spent a great deal of time talking about this, and sort of the discussion points, the major discussion points pulled into sort of 3 areas. One of them identified that essentially we're talking, when we talk about putting packets into the network and how those packets are handled, a lot of these contracts are implicit, right? I'm going to send you a SYN packet and you're going to set up some state on your NAT, and then the next NAT will set up some state, and then a SYN-ACK will come back, and then the firewall will decide that the other endpoint has decided that this is good and delegate that decision. These are all implicit contracts, and maybe we can start tackling this problem by thinking of these as explicit contracts, and having sort of protocol support for setting these things up explicitly. Another thing that came out of this discussion was that encryption provides a tool to enforce a balance of power between endpoints in the middle. One thing I didn't put on this slide is if we can't get cooperation, then we can get compliance simply by weaponizing HTTPS and encrypting everything and saying good luck monkeying about in the transport. And we spend a lot of time on incentives as well. It's great to define a new signaling protocol. It's great to say, okay, well, we have this engineering solution to this problem, but if there's no incentive for anybody to deploy it, and those incentives have to be incremental, right? So if we come up with a new signaling protocol, on day 1, the only thing that's going to talk that new signaling protocol are the first 2 boxes in your test lab. There won't be any middle boxes on the path, and when you ship it, it'll only be endpoints talking. So you have to come up with something that is actually useful for the endpoints first, so that there is an incentive to deploy in the middle. So if you were at the plenary in Honolulu, instead of going and enjoying the beach early, you've seen the 2-stemmed internet martini glass. Bob?
Yeah, it's me again. This thing about TLS being something that weaponizes us, it doesn't, because it doesn't do anything about the transport headers. It's inside the transport headers. I think the hope at the time was that something like TCP Inc. may cover the transport headers, and it's decided not to do that. So we're back at
so the weaponization becomes a harder thing. Yes.
Yeah.
Right. Yeah, because that was before the TCP Inc. discussion concluded there. Good point. So let's actually do this explicitly then. In terms of cooperation, if we have an architecture where we expose what we have to the path to get what we want, encrypt everything else, and make sure that everything else is end-to-end, you end up with the SPUD-BOF. So in SPUD, we're talking about sort of this interlayer right here. which sort of new transports on top of the shim layer, on top of UDP, on top of IPv4 and IPv6. So this is, we're talking about the encapsulation for path exposure and user space transports. That'll be SPUD, or Substrate Protocol for User Datagrams, 9 a.m. Wednesday in the International Room, which I just looked on the map and it turns out that's the plenary room. So we have like 400 seats, so come early, vote often. So the general architecture here is you have, what it looks like to the application is you have the initiator, the responder, there's a bunch of stuff in the middle that the application developers can't deal with, and then from the application developer standpoint, you have the user data, the things that are just the app. This is none of the past business. These would also be application headers. If you were running HTTP here, the HTTP headers would be up in this app area. Transport prime is, and these slides are from Joe, who has a very apps view of this. Stuff the path can't see but ensures the network doesn't burn down, right? It's like the things that the applications are delegating to the transport layer to make sure that the bytes get there and that the internet keeps running. So this is noted as, that's not a typo, this is noted as transport prime. So the idea here is that you have the transport layer itself, it's running in a library, it's running in the kernel, but it's running on top of SPUD, where SPUD is this encapsulation layer. And SPUD contains the things that the applications are willing to share with the path, things that they might be willing to hear from the path, but nothing that has to go on this end-to-end layer. So the generic mechanism that we've come up with in the SPUD-BOF will actually talk about a prototype that I don't want to promise too much, but there were a bunch of people hacking on it at the hackathon. I don't want to say running code at the BOF because that will jinx it, but in the prototype we have right now, basically we have a tube identifier, and a tube is just a set of packets. The set of packets could be a flow, they could be something like an SCTP stream, they could be the set of keyframes within a video stream. It's just however the application decides to package these things together so that it can bind properties to them. There's an in-band channel with an extensible syntax that allows you to take these properties and bind them either to the packet or to the tube. On-path devices can single back to either endpoint using the same in-band channel. And we've got a couple of drafts on this that describe, first of all, the instance of the generic mechanism for experimentation is the prototype, that's draft Hildebrand SPUD prototype. And then some generic constraints for signaling over UDP-based encapsulations is in draft Trammel Stack Evo new T for new transport encapsulation. The A there is not for architecture, but I forget what it is. And there we want to spend a lot of time talking about the vocabulary, right? So if we build a generic signaling mechanism, the success or failure of that generic signaling mechanism is going to come from what you can say, what you should say, what you must say with it. So when looking at this, there need to be incentives to expose information. The application has to potentially get something by saying something. The path has to potentially get something by saying something. Matt, do you want to jump in, or do you want to wait for the end of the slide?
I'll wait.
Okay. And then in the workshop, we split this sort of into two areas. There's the app to path area, so when the application's telling the path things, and the path to app area. And we came pretty quickly to a determination that the app to path thing looks tractable, right? There's probably a minimal set of useful information, things like session lifetime, things like this is my first packet, this is my last packet, where you can actually get some benefit by signaling it, where you can take essentially the transport headers, which are now up in here inside SPUD, inside the crypto. Your mailboxes can't see your SYN flags, they can't see your FIN flags, they can't see the start and stop chunks, they can't see any of the signaling for the transport protocol. But basic signaling for session lifetime so that you can actually set up and tear down state explicitly on these on-path devices, that seems pretty useful, and like it can be done. And this information is also useful to the far endpoint. There are a few other potential use cases that we'll get into at the SPUD-BOF. On the path to app side, the way forward's a little bit less clear. The problem might be tractable. It's basically like ICMP. It would be like in-band ICMP if we treat it as advisory. But the trust issues kind of make the path signaling to the app things that are mandatory very, very hard to deal with. So we might come back to that, but the way forward on that really is much less clear. So coming back out of the semi-workshop, the initial workshop report, I was really hoping to get this out the door before Dallas. I didn't make it, so the deadline on that is real soon now, which means realistically mid-April. Until then, the transcripts, the slides, position papers, everything that has come out of the workshop is up at IEB.org, Activities Workshops Semi. There's been some cooperation with the ETSI forum on middle box issues, actually. Bob, do you want to get up and say like 2 minutes about that?
Okay. I presented the output of the semi-workshop there. I pointed out that a lot of the things that the ETSI NFV group were doing would get broken by end-to-end encryption, and end-to-end, and pointed out how much end-to-end encryption there was. That sort of got people rather scared, because a lot of them hadn't noticed, strangely. So essentially got delegated to the security group at the ETSI NFV industry specification group, and we started to write some guidelines on how to deal, or how to whether and what to do when you're dealing with accessing end-to-end traffic. So things like watching your logs to see whether you're stripping off, getting new functions that you're stripping off and things like that, and a set of functions. So I've encouraged them to come here with Liaison to check that all seems reasonable from their point of view, but I think it's quite nice that they're writing that, because it's the people who write the middle boxes who are writing their own rules, which,
Yep.
Yeah.
Yep.
Right. Okay. So that's a very brief summary.
Are you getting in line for point 4 here, David? Yeah. So one of the other things for the to-do is discussion on transport extensibility and area meetings. So basically, when we're moving forward on this, just sort of how, once we have something more concrete, like basically taking this out, not just to TSV area, but also to apps area, since it's that, they're the clients of this. There's another work item on UDP transport encapsulation guidelines. David.
David Black is one of the recipients of the fine set of scars on this one. TSVWG is working this one. The carriers for this right now there's a GRE and UDP draft that we're going to talk about, and more importantly, the UDP guidelines RFC 5405. There's a 5405 BIS draft. It's in revision. The extent we've got anything new in general to say, that's going to be the carrier for that. So Please come to TSVWG if you care about this. Thank you.
Cool. And then another identified output was a probable IAB statement on architectural assumptions and transport evolution. This has been referred back to the Stack Evolution program. But you can expect something to come out of the IAB soon on that. So further discussions of these points, we have a bunch of lists. Join the lists which interest you. So the middle box measurement issues, the hops BOF, that list is up, the hops at IETF.org, and Aaron will talk about that a bit more. So if you're interested in SPUD, come to the SPUD BOF and join the SPUD at IETF.org. The Transport Services Working Group is working on a lot of sort of the side issues here, and the issues with the application interfaces. That's TAPS at IETF.org, and you just missed it, sorry. I'm assuming that many of you were actually in there. And other future work is handled by the Stack Evolution program. You can mail us at stackevo@ieb.org. So, questions?
Falk Akamai, looking at your,
dual-stemmed inlet martini glass.
John's hourglass. We had this whole discussion in TAPS about real-time apps and RTP.
Yep.
And so it wasn't really explicitly represented. I'm wondering whether SPUD, and I was told that that's how it was pronounced, so whether SPUD is actually, the RTP cabal is aware of this, if there's any big concerns, or your cabal, right? There's two of you.
Cabal? Calling the cabal to the microphone.
Cool. I get to be part
Don't
of
all
the
stand up
cabal.
at once.
Do I get a special shirt or something? Maybe a black dot? I don't know. It's a secret. Yeah, so I'm Colin Perkins. I'm apparently a cabal member. I don't know. I think Spood, whatever. I think there are some good ideas in there. There are some things which concern me.
So we probably shouldn't have that BOF here.
We shouldn't have that here.
But please do in one sentence.
I don't know. I'm not sure I understand it well enough to really give a good answer on the fly like
So
this.
read the draft and come on Wednesday if you have time Wednesday morning, because we do need.
I was, I think, planning on being there.
Okay, good.
I have read the draft, I think. I read a lot of drafts. I mean, I think we have developed, you know, I think RTB has some different requirements because there's a lot of interest in middle boxes which actually do processing and are part of the trust domain in RTP. So I think it has a slightly different set of requirements to some applications, and that I think means that Spud perhaps doesn't work particularly well for a lot of applications.
So one big
although in other
question,
cases maybe it would.
One big question we would have is, does it make sense in those cases where there are trust relationships to be able to represent and exploit them in Spud? And I don't know the answer to that. So basically what we have is just kind of a vocabulary and a mechanism.
Mm-hmm.
And the vocabulary is only expressed at this point in a meta-vocabulary of constraints on the vocabulary. But one of the reasons those constraints are there is we make an explicit assumption that the trust problem is out of scope. But in places where you already have those trust relationships set up and have a generic way to, or a representation independent way to think about them and represent them, then we can certainly represent them in Spud as well, right? Whether or not we decide that's in scope is a discussion for Wednesday.
Yeah, I think there will be a lot of application semantics if you try to bring them in, which is probably too much to bring into a generic protocol.
Probably.
But yeah,
But that's definitely, we're definitely interested in having that discussion.
Bob Briscoe, BT. The reason I went to the mic before and said that it wasn't just a case of TCP versus UDP, but there were some people who believe both, is that I think you're getting rather too focused on SPUD and UDP, and actually there's also the need to look at doing the same thing as you're doing in SPUD in TCP for the cases where UDP can't get through. And that's particularly what I'm doing, but I'm not doing it because I think TCP is cool and UDP isn't. I'm just, two people have got to do two things, and that's the important point that needs to be got over. And I'm looking at, and in TCP it's going to have to be different, but I'm looking at using what are currently the TCP options to talk with middle boxes, because they're the ones that mess with them anyway, and then putting the other TCP options inside the TCP data that you don't want to be messed with. And so that's a thing called inner space.
Yep.
And so you know, I think it's important to go up one level in terms of trying to get consensus on what we're trying to do, rather than saying, oh, we've got to go down either the UTP path or the TCP path. Because
that's a good point. Yeah.
Yeah.
Because so one bit of hallway conversation data that I'm not sure I can quote, but the numbers that were quoted in terms of UDP connectivity is, so 90% of the time between clients and servers you can get UDP packets through both ways, right? Which is, and it works most of the time, sort of thing. But 90% is not good enough for relying on it without having fallback. So if you're in a situation where you can only get 90% of the connections up, then yes, you need to have a plan B.
Mia Kulevin, it's a SPUD chair, +1 to Bob, and come to the BOF, and let's discuss.
Hi, I'm Tim Shepard with this might be a stupid or silly question, but at the base of your hourglass, you had it said 80, it was divided into...
It was divided into two link layers,
802 like and
not 802
Is
like.
802.15.1 802 like?
Not really.
Okay, so that's it's the second time today
Yeah,
I've heard
yeah.
802 and I
Yeah.
had no idea what it meant.
Yeah. So we mean things that kind of have, so link layers that have the properties that TCP was originally designed to so you have some sort of collision
Yeah.
detection or avoidance, you have
But then
a certain
just let me-
profile for...
yeah. Now I'm starting to understand you, and just let me tell you, I don't know whether you invented that term, but I really dislike it.
Okay, I
Because it's
did
confusing.
yeah.
I have no...
Yeah, I did invent that term. I couldn't come up with anything better. If you have a suggestion for
Yeah, good
fixing that
point.
in the next 20 minutes, I
Well,
can change
so-
the slides for the tech plenary, or
Well,
you
then-
can come up and embarrass me at the
Well,
mic
why don't
there
we
as
talk
well.
later in the
Yeah.
hall?
Yeah,
And
let's
you
do
can
that.
explain to me what the distinction really
Yeah.
is you're making, and I'll try to invent
The
it.
big distinction, the big thing that I was trying to capture is that LTE can be pretty painful if you're making decisions about, if you're making 802-based decisions about congestion control.
So is LTE the poster child of not 802
Yes.
like? But it's 802 has so much stuff in it.
Yeah.
Galen Bessler, are you currently envisioning supporting multicast in SPUD? Because the broad
Yes.
definition, I can think of several uses
Yes.
for multicast.
Yes, we are. We are not calling it explicitly out of scope, but if you dig into this tube identifier, there is a ongoing question about the trade-off between using a single tube identifier with multiple 5 tuples, which would then get you the ability to do migration and multicast on the same tube and bind properties to a single multicast session, but would also give you trackability in the mobility case. Versus having tube identifiers somehow linkable to each other in a way that is only exposed to people who already have the tube identifier. So this is something that when we get down into the details of the discussion, the scope of the identifier is one of those things that we need to evaluate the trade-offs on, and applicability to multicast use cases is one of the big inputs to that trade-off discussion.
Okay, well, I'll try to hit the box.
Yeah, cool.
I have a
Thanks.
very specific multicast application.
Excellent.
Jana Iyengar, are you taking more questions on SPUD?
Well, we should make this in the BOF, because that's the place to discuss
Yeah.
SPUD.
That's why I asked the question.
Okay. Yeah.
I have a point to make that isn't about SPUD. Bob Briscoe again. Yeah, and that is the point about when TCP Inc. decided not to MAC the headers or mess with the transport headers. That's sort of, we need to really double take what that means, because we made a decision at the semi workshop that there was the possibility of middle box vendors being interested in talking to us again because of encryption. And now they won't be, because encryption is not going to affect them. So, should we still be just continuing down the path we decided because we thought something else was going to happen and it isn't going to happen?
Another good point.
Yeah.
Okay. So, thank you very much. And we have Aaron with Hobbs.
Wednesday, 9 o'clock, International Room.
Hello. Can I see a show of hands of the folks who were at the Hobbs Barboff on Sunday night? Okay, so most of you actually were there, and so I don't need to say too much. And I don't have slides, so what I'm showing here are my notes, which I'm just going to use to remind me so I don't miss any important points. So as Brian put the Barboff in good context, the idea is we really need some ground truth about what middle boxes are doing, that there's a lot of different kinds of networks and different kinds of middle boxes, and they interfere with protocols in a variety of ways. And there's not a whole lot of measurement of how they interact with transport protocols. There's a few papers out, which we spent some time talking about. But the idea here was to the proposal that we tried to Barboff was to instrument some browsers on fixed and mobile end systems to make active measurements to see what works and doesn't work end-to-end across the internet from a variety of networks, cellular, Wi-Fi, enterprise, university, colo, fixed residential broadband, that sort of thing. The discussion sort of ranged from there. That was sort of what I put on the table. It was what came out of the discussion at the semi-workshop. And the goal is not to necessarily charter an IETF or an IRTF activity, but really just to see if there was interest there, in particular getting engagement from people who maintained stacks and browsers to see about their interest in putting this in. And so there were a number of interesting points that were made, and I'll just try to touch on those very briefly, and to give you a sense of what came out of this. So one of the things that came out was it seems that there's a bunch of information that's already being collected by some end systems, is not necessarily being made public, but I think that the energy level, there were about 60 folks who showed up late on Sunday night, I think will help make some of that information available. So people are trying to get that stuff out there. And so there was sort of the low-hanging fruit of passive measurement, things that are already being collected about behaviors of browsers. And it looks like from Chrome and maybe from Firefox that there's some information from that. And other low-hanging fruit that maybe with a small amount of effort, additional information could be made available. And so that's something that we're going to try to find out what's easily available and share that on the mailing list. And then as we start to talk about active collection, well, of course that takes more work. Not only do you have to write the code, sometimes you have to you need both ends, and then once you start collecting this data, as with the passive data, there are privacy issues, and so it's important to sort of understand the risk versus reward for that. But there was a lot of interest in understanding that, and I think there was general agreement that passive data is only going to help you answer some questions. Localization, one of the ideas was that, well, if you start making lots of these measurements from all over the internet, now you can start to say, oh, gee, these networks are really screwing up the ability to deploy new transport protocols, and maybe, shame them into improving their middle box behavior. Surprisingly, it was a network operator there who said, gee, I don't really know how well this is working in my network, and it would be nice to have a toolkit of some sort so I can understand what's broken and so that I can work with my vendors to get it fixed. And then you can go from there to maybe having a general toolkit that the vendors would use. And so, there's a lot of places where just being able to identify, once you can start to quantify what kinds of, what kind of behavior you want, now people can understand whether they're able to provide it or not. As we were talking about the privacy issues, that the point came out that aggregated statistics are still useful to understand how prevalent certain kinds of bad behavior is, will allow you to make some trade-offs as you're looking at sort of the cost-benefit of doing different kinds of engineering. And so that seems like something that might help us work around some of the privacy issues. There's some folks from Ripe Atlas were there who talked about some test infrastructure that they had that's widespread. This is a way of doing active measurements from nodes in the middle of the network, which allows you to make a certain class of measurements. It doesn't cover everything because, based on some of the research that's been done so far, cellular networks and university networks in particular have been shown to have sort of unusual behaviors compared to a broader class in terms of what the middle boxes are blocking. And there was some discussion about, what do we share? Do we share descriptions of what measurements to make? Do we share the data? I think there's a lot of interest in all the above. And I think that it was a little early to talk about that until we can get some more of the concrete of what's available and what are we going to do. And then just as an aside, there was some discussion about doing fuzz testing where you sort of send all possible permutations of values in packets and see what gets through and what doesn't. And that was, I think there was a pretty strong consensus that because of the state of the stuff in the middle of the network and the size of the state space, that's not going to necessarily give you a very good return for the amount of effort it'll take. So That's sort of the short summary. There's a mailing list, hops at IETF.org, and right now there's the next step is really sort of collect and share some information and see what happens next. But given the interest level, it looks like people are going to continue to plug away at this. And I can take some questions now or talk to anybody offline later. Okay, thank you.
Thank you very much. I think there is David.
Okay, so I'm David Black. I'm not quite sure how it is I got to be standing up here. I think the AD said, gee, you're working on some things. It seemed to have something to do with each other. We found a common theme here. Why don't you explain it to everybody, and maybe they'll have some idea about what else ought to be done. So common theme is diff-serv QoS and browsers. And where this starts from is it's not your father's browser or your mother's browser. Browsers have turned into web application frameworks. The application runs in the browser. An example is JavaScript. People are writing rather fancy applications in JavaScript. Web applications run at the same time. They're separated by this concept of web origin, or they're supposed to be C.RFC, but this is a fancy name for the URI scheme, the host, and the port, which is optional. And that combo is a web origin. Browsers are supposed to separate along those lines of the ones in common use generally get this right. So we get to web application networking QoS. You've got these applications running in the browser. They'd like to have differentiated servers from the network, different QoS by application, more importantly for flows within an application. And WebRTC is a great example, and it's not that simple. So I want to talk about this, but first, let me start with an interruption brought to you by the acronym police, specifically the diff-serv branch. This space is full of acronyms. These are mine. DSCP, Differentiated Services Code Point, that's sitting in the IP header to request network QoS. PHB, we call it a per-hop behavior. This is what the network does when it sees a DSCP. DSCP, the PHP mapping is network specific. Now you start to see why this gets just a little bit interesting. CS stands for class selector. This is a set of specific DSCPs that were selected to carry the former IP precedence concept forward. So CS0 to CS7, you typically see routing traffic running at CS6 in order to give it priority when the going gets rough. CS1 is intended for lower than best effort service, so they're not linear. CS1 is supposed to be lower than CS0 as opposed to be between 0 and 2. More on that in a few slides. Okay, so back to diff-serv and WebRTC. WebRTC means web real-time conferencing, audio, video, data between browsers. Okay, the first is not that simple, is NAT traversal has to work. Every single one of those home router boxes, and I put router in quotes so we don't have to argue about what that really means, has a NAT. It's doing port translation. You're going to get one IP address from your ISP if you're lucky. If you're not, there's more NATs upstream, and you're going to spread it out. So NAT traversal has to work. NAT traversal, when it comes down to it, is about pinhole punching and maintenance. You need to punch a pinhole for every local port that's in use that you intend to run through to run through the NAT so traffic can get back to it. And well, pinhole punching and maintenance, fewer pinholes means less work, probably more robust. Okay, so run all the traffic over the same port, maybe one port. UDP encapsulation is preferred for this. See the comment I made in the middle of Brian's talk. Okay, so we're going to take everything, we're going to take this entire set of audio, video, data. Oh, by the way, probably doing a bulk transfer, so I can send you a slide deck while we're busy talking. We're going to run over one UDP port. What about QoS per traffic type? Okay, a year ago in London, on Sunday afternoon, I sat down with a bunch of people, and we realized that we were horribly confused. What can I say? The result was This was was written to answer this question. I'll show you the draft down in. This led to the DART draft on use of DSCPs with RTP and other protocols. In essence, the DART draft set out to answer the following question: when is it okay to vary QoS with a 5-tuple? Here we're talking about 2 IP addresses protocol, 2 UDP ports. That's how we count to 5. It'd be 2 TCP ports or 2 other ports, but the UDP ones are the really interesting ones here. Answer: only when the transport is UDP, but even then, only with care, it's easy to get wrong. Network may ignore or remove QoS differentiation. More on that on the next slide. We do all kinds of curious things in the network. Big piece of advice: don't vary QoS DSCP or PHB for TCP, SCTP, or DCCP. And the reason is, 1, when you start varying things, if you think about prioritization, you think about different queues in the network nodes. The result is traffic reordering. Protocols that are trying to do congestion response have this nasty habit of misinterpreting reordering as drops of the out-of-order packets and doing a congestion response that you didn't want. Then we get down to multiple drop precedence, which is what if we vary drop precedence within a PHB class? I have one session, I want to apply 3 drop levels. The answer for the reliable protocols is for TCP, nothing useful happens. When you get a drop, TCP does no delivery until it's gotten that packet back. There's no point. For the other 2, we don't have good operational experience. We just don't have a sufficient understanding of what's going on, and so the draft recommends not doing this. Okay, so that's an introduction to this gallery of horrors. What can go wrong if you start varying QoS from the 5-tuple? So I've got this UDP 5-tuple. Over UDP, I'm running SCTP for my data channel. I've got a couple of video channels going, a voice channel. I want to go prioritize things. When the going gets tough, my voice gets through first. Well, network may manage QoS by the entire 5-tuple, not the DSCP within it. So your entire WebRTC session may land in one router queue. Okay, nope, nice. Core networks may limit QoS differentiation. Been working, among other things, with some carriers on what happens inside of core networks. If they do this differentiation at all, 3 to 4 classes are common. It's very easy to come up with a WebRTC application which people would like about a dozen. On the other hand, most QoS problems occur in the edge and access area, and want to toss a word in sideways here for a possible answer to one of the questions that Brian was asking. When is it useful for the path to signal back to the application, and what might it say? Well, it turns out most of your QoS problems occur in getting from the end node to the first node that's really connected to the internet core, because that's where all the Wi-Fi and the cellular and the bad internet home routers are. And if we could just get things straightened out there, we'd make some progress. So it might be that's signaling from a node that's early towards the internet core, but beyond all this edge stuff, back to the application about what's actually going on right now could be quite useful if there's a turn server involved, and for WebRTC there often will be. That could be a possible place to locate that stuff. Okay, onward. Network may remove QoS differentiation. It is very common to remark, I think it's now being called bleaching, to CS0, i.e. best effort at network boundaries. And just when you thought you had this all figured out, I said it earlier, we had to do NAT traversal. Because it turns out we have NATs at both ends. For WebRTC, you need a middle point to sort out the who goes first problem in punching the pinholes. That's a turn server, and turn has this interesting feature that it may decide that you're running over TCP. Sorry, at which point forget it. No differential QoS for you. Next, lower than best effort is a crapshoot. You can use CS1. It might work. It might not. Good luck. CS1 DSCP could result in best effort service. If you're lucky, that's all that goes wrong. If you're not lucky, you've got a classic IP presence implementation on the network that gives you better than best effort. All right, what do I do about it? Well, this is okay.
Did you want to go first, or was it?
I assumed you weren't taking questions at this point.
Let's see, what I'd love to do is get through this slide, the next one, and then I'll be happy to walk back to any slide and take questions.
I'm fine with that.
Will you let me do that and then come back?
I was just going to say there's a sixth problem.
And a seventh, and an eighth, and a ninth. I picked the ones that make my life painful. Okay, so what to do? Here's some of the some initial things. First of all, insulate the web application network via the browser API. Okay, credit to the WebRTC folks, they did this. It's a good start. That's also the punchline to a pile of dead lawyer jokes, because there's no interface to ask what services are, or i.e. PHPs are available. So the net is, you've got this API, which you could set this, which you set these values that translate to a request for a service, and the browser has no idea what services are available. Net is that if you set the DSCP on traffic leaving the browser, it's set and pray. You don't know what's going to happen. There's no good way of network tell you what it's going to do. Next good question. How many QoS service levels? Well, depending on which set of network operators I'm talking to, I get different answers. On the one hand, there's some fairly rich enterprise networks that can easily support a dozen service levels. On the other hand, I talk to core carriers who say 3, 4, no more, please. That's all I'm going to do. MPLS in particular turns out to be a very strong influence here, because the QoS is carried down in the TC field inside the MPLS label. Current WebRTC QoS draft uses a lot of levels. The goal is to try to get some differentiation, at least at the sending edge. Open issue there, TBD. Also, given that what I said in the first slide, lower than best effort via diff server is a crapshoot, should at the very least don't try for lower than best effort service unless it is completely okay to have all that what you thought was background traffic carried as best effort. If that's not true, you're taking a risk that the network is not going to help you. And then just if you want to explore further, here are 3 relevant drafts. Dart draft was dealing with how to use diff-serve QoS with WebRTC. There's WebRTC QoS draft that's trying to fill the next set of pieces, which is mapping from application classes. This is audio, video, text, audio, video, data, things like that, onto what you ought to be asking network for. And diff-serve interconnect draft, which is an interesting effort that I hope works out and gets deployed, about putting in place a framework that we hope helps enable carriers to do something other than bleach all the QoS differentiation to CS0 best effort at interfaces. And with that, John, which slide do you want me to go back to?
It doesn't matter. I can just ask you the question.
I'm in trouble regardless. All right, I saw that one coming.
Because this is so Jana Iyengar, this is a hard problem, and kudos to you for actually taking it on and plowing through this mess.
I think I'm sitting here understanding what you touch, you own it means.
I understand. I have a couple of questions. One of them is about their use of the term DSCP. When web apps are talking about DSCP, are they talking about actually what they would like to have from the network, or are they actually talking about the bits on the wire? Because it seems like you're jumping a layer here. And it seems like this may be a bit too much information that an application is trying to chew off. Given that the application may not be aware of the congestion control context that it's sitting on top of.
I'm going to tell you that WebRTC got this right. The interface that a WebRTC application uses has no concept of DSCP. It has a notion of the class of traffic it's sending and the level of service it would like for that class of traffic. The browser framework is then responsible for mapping that interface onto the DSCP, hopefully with some knowledge of what PHPs are available. So that's the first bullet up here. The WebRTC got it right. There are some problems in trying to build a browser framework because you know what's out there.
Yeah, I understand. So you said a few things in the previous slide, if you go back one slide before this, where, one more. There we go. So don't vary costs for TCP, SCTP or DCCP. Well, for SCTP, you can have multi-home connections, you can have different congestion control
Can I
contexts.
cut you off there because you're re-exploring an issue that is answered in detail in the DART draft. Let me tell you to go, please go read the DART draft. I had extensive conversations with the SCTP community. This is the IETF rough consensus, which is don't do SCTP. We need some major experience with what's actually going to happen, how it's actually going to work. I apologize for interrupting you, but I've got the scars. I was about where you were about 6 months ago going, come on, we've got to be able to do this with SCTP stream. The answer is no, and the fundamental reason why is that there's two of them. One is the SCTP congestion control context is the whole session. It's not stream by stream. Number two is, let me finish.
You got me wrong though.
Okay.
I didn't say multi-streaming, I said multi-homing. There is experience that we have with using multiple network interfaces inside of one SCTP connection. Each network interface is a separate congestion control context. You can have a whole bunch of SCTP streams mapped into one congestion control context there. The point I'm trying to make here is that an application doesn't necessarily know exactly how it is getting mapped onto congestion control contexts. The entity that is doing the congestion controlling will know more about this and ought to be responsible for setting the DSCP bits.
Would be interested in seeing details of how this works out. The conclusion when we did the work on the DART draft is there's some potential for that. Not so much that. There is potential particularly for the multiple drop, there's particularly for multiple drop precedents, and this may fall in the same category, but there was limited, if any, operational experience, and at least when I was working on the DART draft, the answer was for the PHB selections, for drop precedents, lack of operational experience suggested, let's make sure we know this works first.
That may have been for multi-streaming, and I'm happy to talk later on about multi-homing, but I think my higher order point was that the congestion controller ought to be responsible for how DSCP bits are set. Wherever there is one congestion control context, it's okay to have one DSCP code point, and the reason is because a congestion controller is trying to determine characteristics of the path. A new DSCP code point results potentially in a different path. And by path, I mean different properties of the path.
I'm uncomfortable with a congestion controller setting DSCPs. There are other good things they can do, ECN bits in particular. I think what you may want to do is expose the multi-homing up through the API and get the browser involved in setting that up.
I'll eat some of my words, and I'm going to take this offline if you want to continue this conversation.
Okay, fine.
Robles, KIT, can you please move forward one slide? Yeah, the fact that lower effort is more or less random outputs, right, is not a property of the service itself. It's just a matter of that the DSCP to PHB mapping is very, I mean, it's just a recommendation in the RC, in the original RC for lower effort, and so I guess this is an outcome of the flexibility of the DiffServ architecture, that you can have various mappings from DSCP to PHBs, and every provider can do it in their own way. And I guess maybe the interconnection draft of Rüdiger is some way of moving forward, having common, let's say, recommendation for DSCP to PHB mappings. Right.
That would be the third draft here. I'm actually a co-author on that one. Hoping to move forward. However, lower effort is not one of the traffic classes that draft is addressing, and the rest of your comments about DiffServ are basically on the mark. They happen to be worse for lower effort than some of the other PHBs, but
I guess one reason for that CS1 inversion is maybe the idea of having same mapping as in 802.1q, right?
Once upon a time.
Magnus Westland. About Hager's comments before about SCTP multipath, I mean, the problem with SCTP, at least in the WebRTC context, you only have one path. You can't do any tricks there anyway, so... Well, okay, I mean, if you're thinking about I understand your comment about that you can treat different classes as being as different six tuples and therefore treat them as different context. I can understand it, but that means changes to SCTP as I understand it, but yeah.
Yeah, I mean, if at the end of the day, turn punches you one pinhole, that's what you've got.
Michael Wetzel, I have a quick comment about this lower than best effort thing. I think the congestion control mechanisms that are done in our MCAT now, they're all delay-based. Changing them to be lower than best effort would be a super simple change, I think. I think it's just because it's hard to make them not best effort, right? I mean, not lower than best effort. So if you just remove some of this extra, it becomes a lower than best effort scheme, you have it. It's very easy, I think. If that is a requirement, the group could probably do that.
I think widespread availability of those is something we can all look forward to.
Andrew McRae, yeah, I agree but that's not doing lower than best effort directly via diffserv. The real thing that makes it a crapshoot is that there are very widely deployed systems, like a large fraction of the world's home routers, that do have that inversion that treats CS1 as higher than best effort priority. And that's an unfortunate bug, but it's so widely deployed, it's the deployed state of the internet.
Anybody else?
One more comment. I mean, this actually relates to, this is Magnus Westlund again, about WebRTC and this prioritization. I mean, WebRTC is not only applying diffserv level prioritization, it's also including scheduling prioritization on the outgoing stream. So, and that's, I think, worth noting. So you actually get something from the congestion controller and the scheduling for transmissions.
Okay, I think that's it. Thank you all.
Oh, cool. Thank you. There we go. Just a heads up. We're rolling the heads up. Cool. You just speak about that one? Sure. Such a deal. You want me to go? Yeah. Cool.
So for the rest of our time together here, I wanted to have a short heads up about some of the discussions that we're having on the ISG about, that are relevant to TSV. Not most of them are not so TSV specific. Some of them are. If you've noticed anything about changes to the area structure and to the number of area directors per area and things like that that have happened in the past 6 months or so, there's actually been a lot more going on than there has been in previous years. What we're trying to do on the ISG is recognize the changing world and reflect new ways of working, changes in topics, and the need for flexibility. Yari is going to be talking about this in some detail at the plenary on Wednesday also, so I wanted to be sure and give you guys some chance to be thinking about that. So some of the things that have already happened, we've done the thing where we can assign area directors to working groups that are not in their area. That's started out being a lot of the work that we were doing to move operations working groups out from under Benoit so that he could focus on a lot of the Yang model work that's being done. So if you've seen anything about that, that's what's going on with that. If you look at the list of working groups on the charter page, you'll see some of them in operations have a responsible area director that's neither one of the existing ops area directors, and that's what's going on with that. We did a more flexible definition of area directors, and if you saw RFC 7475, which basically said we were able to have more than 2 area directors in an area, the first area that's taken advantage of that has been routing. If you guys will see 3 area directors seated for the next coming ISG on Wednesday night. That's what's going on with that. We're doing a lot of focus on data models work with, like I said, with Benoit and then with the coordinator group. And if you guys have seen discussions, this is still in process, but reorganizing the Epson area and the Rye area into one area called ART. And that's going along with going down from 3 ADs from 4. We're still in the process of creating the ART area. One of the things that is going on there is that we have Alyssa Cooper is on maternity leave right now. She's one of the affected area directors, so we're kind of waiting for her to get back so we can do more with that. And then some things with moving various working groups between areas and between AZs due to all this. So the thing I wanted you all to be thinking about, the ISG is doing a lot of work on trying to improve the way things work around here. So far, very little of it has been transport specific. So number one that goes along with that is that the transport area has more tools available now than a lot of us think about, because these tools were put in place to solve other problems, but we can use them as well. But the other thing I think I wanted to say was that we've still got work to do on the transport area beyond where we are right now. And one of the big things, passions that I've had, and we've talked about it at various TSV area meetings since I became area director not quite 2 years ago, is basically saying we want to make sure that the transport area has the management that the area deserves. And so that some of that will be making sure that, actually a lot of that will be making sure that the area directors that this area needs are able to serve, that this is a manageable commitment for them. And that's been a not, transport is not the only area that's experienced that, but transport has had difficulties with that in the past, and Martin and I would really like to change that. There are things that we can take advantage of now that, and RFC 7475, where we have the opportunity of using 3 area directors where we had only 1 or 2 as the possibilities previously, being one good example of this. But like I said, there are others. But there may be things that we need to do that are specific to transport. And I'm kind of, the thing I wanted to be sure to say is that we're willing to do those things. We're willing to work on trying to make that realistic. It's been, you can observe that it's easier to get people to sign up for a second term as area director than it is to get them to sign up for a first term. Martin is in his second term right now, and I'll be starting my second term on Wednesday night. So we've had some time to try to get things in place. We've gotten some stuff in place. We have more work to do, and I would just encourage you guys to be part of the conversation about doing that. I am here all week. Please grab me in the hallway and talk with me about what you think the needs of transport are that we need to do things about. Martin, anything?
I think that's.
So, like I say, we can chat for a minute or two here if people have things that they'd like to chat about. But like I say, recognize we'll have discussion at the Wednesday night plenary, admin plenary at open mic time, and that we've got time slotted on Friday TSV area session give you guys more of an opportunity to do feedback and share ideas, given that you've had some time to think about it.
I think I won't say too much about this, but I think one thing we should consider in terms of restructuring is that there is more and more work in the applications area that's actually doing transport work, like HTTP2 was very much a transport protocol, and it's not really getting reviewed in the transport area, and the two seem to be a bit disconnected, so there may be some structural problem there. I can talk about it more, maybe I'll talk about it more privately, and then we can frame it. But yeah.
I would encourage people also, feel free to send email about this to the TSV area list so that people have a chance to think about it before Friday.
And that's why I've raised it, just so people can think about the issue and how it might be dealt with.
And maybe one last slide. For instance, one thing which is being discussed in the ISG, but also maybe with people who are interested to become AD in the future, is the first bullet here is reducing the time commitment that somebody has to be an AD. Right now it's something like 75 to 100%, but we want to get it down to 50%. And there would be quite good if you have views on that and maybe also ideas how we can get there. And what Bob mentioned is there are maybe some things we should talk about the future of the structure of the area. And yeah, we're going to do this on Friday, hopefully with like good input from you guys. Any other question? Question for me maybe, where are the blue sheets? If we talk about structure. So they're gone, damn.
Oh no.
So where are the blue sheets, please? Did anybody not sign the blue sheets?
Has anyone seen a blue sheet in the past hour and a half?
Excellent. Excellent. So maybe if you bring it up, you can bring it to the people who didn't sign it. Okay, thank you. And that's the end of the session for today. See you again on Friday. Thank you. Done.
I did that review on Teams when we do most of the
Yeah, the thing is that I think it's not our side is this. I haven't told you because I don't know it. Yeah. So what we're working on is now we're planning on so-called triage.